Have you ever pondered why Mars, our celestial neighbor, has such a distinct red hue? The red planet, as it's often called, has long been a source of intrigue and curiosity. Its unique scarlet color sets it apart in our night sky, sparking interest and speculation. This allure isn't just skin-deep though. Mars's crimson facade is just the beginning of its fascinating story. From its dusty surface to its thin atmosphere, every aspect of Mars has its own tale to tell. Each component forms a piece of an intricate puzzle that scientists have been trying to solve for centuries, and the more we learn, the more we realize how much there is yet to discover. So what makes Mars, well, Mars? What are the building blocks of this intriguing planet? That's the question we'll be exploring in this series. As we delve into the components of Mars, prepare to embark on an interplanetary journey of discovery. First, we touch down on Mars's surface, a spectacle of awe and mystery. A world that has captivated our curiosity for centuries, Mars is a vast tableau of alien landscapes, painted with shades of rust and crimson, a testament to the iron oxide that dominates its surface. This iron oxide, more commonly known as rust, gives Mars its iconic red tint, earning it the nickname the Red Planet. But Mars isn't just a monotonous sea of red. Its terrain is a diverse collection of features that rivals, and in some cases outclasses, those found on Earth. Towering above all else is Olympus Mons, a shield volcano whose scale dwarfs any terrestrial counterpart. Standing at a staggering 22 kilometers high, it's not just the tallest volcano on Mars, but the tallest in the entire solar system. Imagine, if you will, a mountain 3 times the height of Mount Everest, its base stretching across an area comparable to the state of Arizona. Yet, the grandeur of Olympus Mons is rivaled by the Valles Marineris, a canyon system that stretches across the Martian equator for over 4,000 kilometers, making it the longest canyon system in the solar system. That's about 5 times the length of the Grand Canyon, and in some places it's as much as 7 kilometers deep. Mars also boasts polar ice caps, much like our own planet. Composed largely of water and carbon dioxide, these ice caps wax and wane with the Martian seasons, providing a stark reminder of the dynamic nature of this distant world. And let's not forget the dust storms, some of which can envelop the entire planet for months at a time. These storms, while a challenge for robotic explorers, contribute to the ongoing reshaping of the Martian surface, a process that has been taking place for billions of years. The surface of Mars, with its vast valleys and towering volcanoes, paints a picture of a world alive with geological activity. It's a landscape that invites exploration, promising discoveries that may reshape our understanding of the Red Planet, and perhaps of our place in the cosmos. Leaving the surface behind, we ascend into Mars' wispy atmosphere. This is where the Red Planet truly begins to differentiate itself from our own Earth. Unlike the nitrogen and oxygen-rich atmosphere we breathe, Mars's atmosphere is primarily composed of carbon dioxide, making up a whopping 95% of its atmospheric gases. This carbon dioxide-dominated atmosphere is accompanied by the presence of other gases in smaller quantities. Nitrogen, the most abundant gas in Earth's atmosphere, is found in Mars's atmosphere too, but it only constitutes about 2.5%. Argon, on the other hand, makes up nearly 2%, with the remaining trace amounts made up of oxygen, carbon monoxide, water, methane, and a few other elements. Now, while the composition of Mars's atmosphere is fascinating, its thickness, or rather thinness, is equally intriguing. Mars's atmosphere is incredibly thin, about 100 times less dense than Earth's. This thinness plays a significant role in the planet's climate and weather patterns. On Earth, our dense atmosphere acts as a protective blanket, absorbing and redistributing the sun's heat, which results in a relatively mild climate. Mars's thin atmosphere, however, doesn't offer the same benefits. It's unable to retain much heat, making the Martian climate extremely cold. The average temperature on Mars is a chilly -80 degrees Fahrenheit, with winter temperatures dropping to a bone-chilling -195 degrees near the poles. Moreover, this thin atmosphere also means that Mars experiences less weather activity compared to Earth. The planet's weather patterns are typically characterized by dust storms, which can envelop the entire planet and last for months at a time. These storms are driven by the thin atmosphere and the planet's dusty surface. In conclusion, Mars's atmosphere, composed primarily of carbon dioxide, with traces of nitrogen and argon, is a thin veil that plays a crucial role in the planet's climate and weather patterns. And while it may not offer the same protection or conditions as Earth's atmosphere, it adds to the intrigue of the red planet. The thinness of Mars's atmosphere, a blanket of carbon dioxide, makes for a frigid and dry Martian world. Beyond the atmosphere we encounter Mars' elusive magnetosphere. But what exactly is a magnetosphere? Picture an invisible shield around a planet generated by the planet's magnetic field. This shield plays a vital role in protecting the planet from the sun's harmful solar winds. Solar winds are streams of charged particles that the sun continuously ejects into space. Without a strong magnetosphere, these solar winds can strip away a planet's atmosphere, gradually eroding its ability to sustain life as we know it. Now let's talk about Mars. Unlike Earth with its robust and encompassing magnetosphere, Mars sports a weak and patchy one. Imagine an umbrella full of holes trying to shield you from the rain. It's not going to do much good, is it? That's essentially what Mars's magnetosphere is like. It's there, but it's not doing a stellar job. This weak magnetosphere is likely a result of Mars's core cooling and solidifying over billions of years. A planet's magnetosphere is generated by its liquid core. As the core cools and becomes solid, the planet's magnetic field weakens, leading to a weaker magnetosphere. So how does this impact Mars? Well, it's a significant factor in its atmospheric loss. Mars's thin atmosphere is continuously being stripped away by solar winds due to the planet's weak magnetosphere. This has led to Mars becoming the cold, barren world that it is today. As the atmosphere thins, the planet's ability to retain heat decreases, leading to colder surface temperatures. In the grand scheme of things, Mars's magnetosphere is a silent player, often overlooked, but with a significant role in shaping the planet's present and future. It's a testament to the intricate interplay of cosmic forces that govern our universe. Mars's patchy magnetosphere, a weak shield against solar winds, is a key player in the planet's atmospheric loss. This is just one piece of the Martian puzzle, a testament to the complexity and intrigue of the red planet. Finally, we reach the companions of Mars in its celestial journey, Phobos and Deimos. These two moons, unlike our singular satellite, are not quite the picture of round, glowing orbs that we're used to. They're more akin to misshapen potatoes tumbling through the Martian sky. The discovery of Phobos and Deimos dates back to the year 1877, when American astronomer Asaph Hall spotted them through his telescope. Their names derive from the Greek words for fear and panic, aptly named after the horses that pulled the chariot of the war god Mars in Greek mythology. Phobos, the larger of the two, is a mere 16 miles across. It orbits so close to Mars that it completes an orbit in just over 7 hours, which is faster than Mars rotates. This means, from the surface of Mars, Phobos would appear to rise in the west and set in the east, twice in one Martian day. Deimos, on the other hand, is only about 9 miles in diameter and takes a more leisurely 30 hours to complete its orbit. This tiny moon is so small and far away that from Mars, it would appear star-like to the naked eye. Now you might be wondering, how did Mars end up with these two odd companions? Well, the prevailing theory is that Phobos and Deimos are captured asteroids. Pulled in by Mars's gravity, these space rocks found themselves locked in the planet's orbit. But these moons are more than just celestial curiosities. They have a significant impact on Mars. For instance, Phobos's gravity interacts with Mars, causing tides in the Martian rock, slowly altering the planet's shape. Moreover, studying these moons can offer clues about the early solar system and the process of planet formation. So there you have it. Phobos and Deimos, Mars' celestial companions, add to the intrigue of the red planet. From its iron-rich surface to its thin atmosphere, and from its weak magnetosphere to its asteroid-like moons, Mars is a world of contrasts. We've journeyed through the red planet's unique aspects, each component painting a different facet of this enigmatic world. The dusty, iron-rich surface, a testament to its volcanic activity and potential for life. The thin, carbon dioxide-rich atmosphere, a stark contrast to our own and a challenge for potential colonization. The weak magnetosphere, a window into Mars' core and a barrier or lack thereof to solar radiation. And finally the two moons, Phobos and Deimos, more akin to asteroids than moons, whispering tales of Mars's past. Each component is a piece of the puzzle, a step in our quest to understand this captivating planet. Understanding these components brings us a step closer to unraveling the mysteries of Mars, our captivating neighbor in the cosmos.